Hello everyone, welcome to this tutorial on panel connections and software interface. In this tutorial, we will learn about various terminals on the panel, accessory set, and software interface. We will also learn to demonstrate Ohm's law, effective resistance in series combination, effective resistance in parallel combination, and show the circuit diagrams of our experiments. Here I am using Expeyes version 3.1.0, Ubuntu Linux OS version 14.04. To follow this tutorial, you should be familiar with Expeyes Junior interface. If not, for relevant tutorials, please visit our website. Let's discuss about the utilities of Expeyes Junior device. The device can be used to carry out experiments in higher secondary, undergraduate, electrical, and electronics engineering courses. It can be used in fields such as electricity, sound, magnetism, light, diode, transistors, and others. Let's begin with terminals on the top panel. Panel has 4 ground terminals. At these terminals, the voltage is 0 volt. Voltage measured at other input terminals is with reference to ground terminals. Input terminals A1 and A2 can measure voltage between -5 volt to +5 volts. On the left, in1 and in2 terminals can measure voltage between 0 to 5 volts. In1 also measures capacitance up to 5000 picofarads with good accuracy. PVS is programmable voltage source. It is used to deliver voltages between 0 to 5 volts range with a minimum step of 1.25 millivolts and can deliver up to 5 milliamps. Sine delivers a constant frequency around 150 Hz at an amplitude around 4 volts. Sen is mainly used for connective sensor elements like phototransistors, light-dependent resistors, thermistors, etc. It is a voltage measuring terminal with an internal 5.1K resistor connected to 5 volts. SQR1 and SQR2 terminals can generate square waves of 0 to 5 volts with a frequency from 0.7 Hz to 100 kHz. OD1 produces a digital output as 0 volt or 5 volt under software control. Mic captures sound from an external sound source. CCS means constant current source. It gives 1 milliamps current with a load resistor of 3 kilo ohms since voltage should be kept below 4 volts. Inverting amplifier is used to amplify external voltages. It may be used to amplify external condenser or mic output. Along with the device, some accessories are provided. Accessories list include 2 piezoelectric discs, 2 3000 turns coils, DC motor, screwdriver, set of 4 permanent magnets, 4 crocodile clips with wires, transistor, 2 silicon diodes, LDR and thermistor, capacitors, 4 5 mm LEDs, 4 wires, resistors. This is a graphical user interface of Expeyes Junior. GUI is known as plot window. On the left side of the plot window, we have input terminals A1, A2, In1, In2, Sen, SQ1 and SQ2. ATR, WHI and other trigger sources are used to fix the waveform. We will discuss about ATR, WHI and other trigger sources in the upcoming tutorials. CH1, CH2, CH3, CH4 are plotting channels with sliders. Channel sliders on the right are used to move the waveform on the plot window. Click on A1 and drag to CH1. We can see the connection information in the box below. Click on A2 and drag to CH2. We can see the connection information as before. Drag channel CH2 to fit. It shows the voltage and frequency of A2. Drag CH2 to NML. It removes the display shown by fit. Milliseconds per division represents time axis. Volt per division represents volt axis. Trig level is a trigger controller. Click on CH2 and drag to del. It removes CH2. Click on CH1 and drag to del. It disables the display of CH1. FTR generates Fourier spectrum of the wave. Under setting square waves, we have a number of input and check boxes. In this input box, we can change the frequency of the wave in Hertz. This is to change phase difference, dphi in percentage. In set PVS is equal to input box, we can enter the desired voltage value between 0 to 5 volts. Press enter to set the value. SQR1, SQR2 and both checkboxes are used to activate the frequency. Frequency can be changed using the slider. Set state checkboxes are used to control OD1 and CCS. Measure C on IN1 button is used to measure capacitance. Measure R on Send button is used to measure resistance. Below the buttons we have a command window to type Python code. We will discuss about Python code in upcoming tutorials. Save traces to button to save traces as .txt files. We will discuss about loop checkbox, scan and XMG buttons in later tutorials. Experiments button displays list of experiments. Quit button is used to close the window. Now I will demonstrate Ohm's law using the device and its interface. In this experiment, we will show the dependency of voltage across a resistor and verify Ohm's law. The device is connected to the system. In this experiment, PVS is connected to IN1 through 2.2 kilo ohms resistance. IN1 is connected to ground through 1 kilo ohms. This is the circuit diagram for the connection. Open the software interface. In the plot window, click on IN1 to measure the voltage. For PVS equal to 1 volt, the corresponding value of IN1 is 0.309 volt. For PVS equals 2 volt, IN1 value is 0.619 volt. For PVS equals 3 volts, IN1 value is 0.928 volts. As an assignment, change PVS values from 0 to 5 volts and check the corresponding IN1 values. Let us perform an experiment to check the effective resistance in series combination. In this experiment, we will show the voltage when resistors are connected in series. In this experiment, IN1 is connected to CCS. CCS is connected to ground through a resistor. On the plot window, select the CCS checkbox. Click on IN1 to show the voltage. This is the circuit diagram for the connection. When 1 kilo ohm resistor is connected to CCS and ground, measured voltage is 0.979 volt. Likewise, for 560 ohms resistance, measured voltage is 0.543 volts. For a series combination of 1 kilo ohms and 560 ohms resistances, measure voltage is 1.5 to 4 volts. Let us perform an experiment to check the effective resistance in parallel combination. In this experiment, we will show the voltage when resistors are connected in parallel. In this experiment, in1 is connected to CCS. CCS is connected to ground through a resistor. This is the circuit diagram for the connection. On the plot window, select the CCS checkbox. Click on in1 to show the voltage. The experiment is first carried out with 1000 ohms resistor, then with parallel combination of two 1000 ohms resistors. This is the circuit diagram for 1000 ohm resistance in parallel combination. The measured value of in1 is 0.952 volts. This is the circuit diagram for parallel combination of two 1000 ohms resistors. The measured value of in1 is 0.474 volts. Again, the experiment is carried out first with 2.2 kilo ohms resistor, then with parallel combination of two 2.2 kilo ohms resistors. This is the circuit diagram for 2.2 kilo ohms resistance. The measured value of in1 is 2.132 volts. This is the circuit diagram for parallel combination of two 2.2 kilo ohms resistance. The measured value of in1 is 1.063 volts. Let's summarize. In this tutorial, we have learned various terminals on the panel, accessory set, and software interface. We have also learned to demonstrate Ohm's law, effective resistance in series, effective resistance in parallel, and show the circuit diagrams of our experiments. As an assignment, measure the effective resistance using a combination of series and parallel resistors. This video summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. We conduct workshops using spoken tutorials and give certificates. Please contact us. The spoken tutorial project is funded by NMEICT MHRD Government of India. This tutorial is contributed by Kaushik Datta and Madhuri Ganpati. This is Sakina Sidhwa. Thank you for joining.